If alpha and beta are the roots of the equation, listen carefully. If alpha and beta are the roots of the equation, x squared plus 5x plus 6, find alpha squared, or evaluate alpha squared plus beta squared. Now, in this regard, what is alpha? What are the roots of this equation? Minus 2 minus 3. Do you all agree on that? All right, so minus 2 minus 3. That would be, so I'll just have minus 2 all squared plus minus 3 all squared. What will I get? 9, giving you 13. Good. However, it's not every equation that you can easily figure the roots out. Or sometimes, even if you can get the roots, it will be too long a process. So we have to come up with another way of doing the same thing. So watch what I'll do. Alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Now, what is alpha plus beta over here? Is the same as, no, it's the same as minus 5. Do you agree on that? Do you agree? Because minus b over a. So instead of finding the roots to get this same thing done, there's another way I can go about it. That would be sum of roots will be equal to minus 5 all over 1, giving me minus 5. Agreed? Then what would alpha plus beta be? That would be what? Alpha, good. Alpha beta. That would be what? 6, which is c over a. Just 6, c over a, 6. So now, substituting it over here, I would have minus 5 all squared minus 2, 6. What's minus 5 all squared? 25 minus 12. What do I get? Do you get that? So all the various variety of things we are doing over here, don't be seeing, that's why I said earlier on, don't be seeing them as some things to just be chewed. They're actually shortcuts to make your work easy. So I've just used this example to explain how it's working and how easy it can be using them. The next work to do is where these things are coming from. How did this and this just become this all of a sudden? Is that okay? So let's go there and prove that as well. We got this from, we are looking for alpha squared plus beta squared. But from our concept in binomial theory, we know that alpha plus beta all squared is the same as what? That will be alpha squared or a squared plus 2ab or 2 alpha beta plus what? B squared. So therefore, alpha squared plus beta squared will be equal to, bringing this one here, right? So it will be alpha plus beta all squared minus 2 alpha beta. Now, we have it this way also because we want the ends over here to be values of alpha and beta and then alpha beta, because those two guys are easily found from equations using minus b over a for this and c over a for this as well. Do you get that? So it means that are you okay, Abigail? It means that I shouldn't get something like alpha minus beta at this end. If you observe them carefully, they are all like that. Look at alpha, beta in that form, except this one. But this one, you can substitute it with all of this. which has just alpha plus beta and alpha beta inside. Do you get that? So first one, let's see the second one as well. What about alpha minus beta all squared? We have alpha minus beta all squared. This same thing can be written as alpha plus minus beta all squared, right? Does that make sense? Okay. So this will be equal to alpha squared, substituting it into this form, alpha squared minus 2 alpha beta plus beta squared. Do you agree on that? Perhaps come, is there? The 2. Yes, it's from this side. But since our b is now minus, it becomes minus 2ab instead of just 2ab. Can I move on? Are you sure? So now I have alpha squared plus beta squared minus 2 alpha beta. But this alpha squared and beta squared is also the same. You are trying everything possible to have just alpha plus beta and then alpha beta at the other end. Okay, so I'll now have alpha plus beta all squared minus 2 alpha beta minus 2 alpha beta. So I'll have alpha plus beta all squared minus 4 alpha beta. Do you get that? Do we get it? Are you sure? Questions? Where from? You mean this one? This one? Okay, yeah, it's from this place. You know alpha squared plus beta squared from the first proving is alpha plus beta all squared minus 2 alpha beta. So I just brought all of this and substituted it here. So I'll now have this and then plus the already 2ab there. So I now have alpha plus beta all squared minus 4 alpha beta. Are you okay? Any other questions? Mukunu, are you okay? Alright. Now the third one. Alpha minus beta is equal to root of, this is already makes sense. In that if it's alpha minus beta, you just find the square root of this guy to arrive at this. Hello. Alright. So now I have root of alpha plus beta all squared minus 4 alpha beta. Alright, the fourth one. 1 over alpha plus 1 over beta. You can just even go with the butterfly method. You know the butterfly method of solving fractions. You go this way, 1 over alpha plus 1 over 2 plus 1 over 3. Do you remember this? It's class 4. It's called the butterfly method. You cross like this, cross like that, and multiply this side. So 3 times 1, 3, 2 times 1, 2, 2 times 3, 6. You get 5 on 6. Okay, 2 over 3 plus 4 over 5. Let's go. It becomes 4 times 3, 5 times 2, 3 times 5. So that will be what? Is that okay? Alright, hello. Are you okay on that? It's a trick or something. It's been there. So this one too, if I go this way, go this way, go this way, I'll have what? All over. Good. Now here, The fifth one is a lot more like the one we just saw. So I have 1 over alpha squared plus 1 over beta squared. I do that. Do you get it? Butterfly, I'll get alpha squared plus beta squared all over alpha squared beta squared. But this top is also alpha plus beta. Everybody, I can't hear you people though. Okay, all over. How can I represent this to just be alpha and alpha beta? It becomes what? Alpha beta all squared. Is that okay? What's left? Alpha cube plus beta cube. What's the expansion? So let's start from what's the expansion for alpha plus beta all cube? Use your Pascal triangle. It'll be what? Alpha cube plus Fred, what's the next term? Alpha cube plus 3 alpha squared beta plus alpha cube plus 3 alpha squared beta plus oh, we knew alpha cube plus 3 alpha squared beta plus. We've done binomials, so I'm expecting that you have answers to this. Wow. Abigail. Three alpha beta squared. Good. Plus you, Stella. You. Plus, what's the last one? Alpha cube plus 3 alpha squared beta plus 3 alpha beta squared plus plus yeah, you know, what's the last thing to add there? Plus beta cube. Yes. We've done binomial expansion, so you know to whether I see A or beta is the same thing. So when you see beta, just go with that. All right. Did you get it? Did you get it? Oh, okay, no problem. So I'm actually looking for alpha cube plus beta cube. So I can therefore go this way. Alpha cube plus beta cube is equal to alpha plus beta all cube minus what? Or I think better we should simplify from this side first. Let's do that. Alpha plus beta all cube is equal to alpha cube plus. No, what we want to simplify this. 3 alpha beta alpha plus beta cube. So it would be equal to alpha cube plus beta cube is equal to alpha plus beta minus so we have the last one, alpha squared minus beta squared. What concept can you see here glaringly? Difference of two squares. So that will be alpha plus beta and then alpha minus beta. And since alpha plus beta is already part of what we've been looking for, alpha, yeah. Yes, yes, you could, but then you have to signify it. That let A and B be the roots of the equation. But again, I already said that even me, I find it difficult keeping to one of them. So you see me mixing it, but that shouldn't be the ideal. You have to stay with alpha throughout. Okay, so I'll just maintain the alpha plus beta. Then alpha minus beta, I can come where? Here. All right, point 3. Then I'll just substitute it over here. Multiplying root of alpha plus beta all squared minus 4 alpha beta. Is that okay? Are you okay? All right. So we'll solve a lot more questions on these things. And we'll master it. Okay.